Hi everyone, I'm Bowan. I'd like to introduce our paper, Exploiting KNIP for Zero-Shot HOI Detection Requires Knowledge Distillation at Multiple Levels. This work is supervised by Prof. Tinne. Here is the outline. Firstly, I'd like to introduce some background knowledge of HOI detection. Given an image, HOI detection aims to detect the human and objects as well as recognize their interaction types. For weakly-supervised setup, only image-wise supervision are provided during training. In other words, human and object locations are not given for training, while the inference stage are the same. In this work, we proposed a new problem setup. Even though weakly-supervised HOI detection can largely reduce the labeling cost and enhance robustness to label errors, it still needs image-wise annotations, which are costly to obtain and often noisy and incomplete. In this work, we aim to discard all human annotations and solve the challenging HOI detection task with only pre-trained models. In this way, we can avoid the bias from human annotators. We call this new setup as zero-shot HOI detection, which is similar to zero-shot image classification, but more complicated as it involves the fine-grained and multiple human-object interaction understandings. Here is the overview of three HOI detection setups. A is fully supervised, where full HOI annotations are given. B is weakly supervised setup, where only image-wise categories are provided. Here, we target on C, a zero-shot setup, that no annotations are provided. We aim to address this challenging task by multiple-level knowledge distillation from pre-trained KNIP. Specifically, we formulate the detection task in a two-stage schema, where the first stage will generate human and object proposals with an off-the-shelf object detector. And the second stage, we pair up all human and object instances and classify their interaction types. Here, we focus on the second stage. As HOI relations manifest across various levels, including global images, relational union regions, and individual human and object instances, intuitively, we should learn the HOI representations on multiple levels. Specifically, we leverage KNIP model to learn the representation, where we use the image encoder to compute image feature map, and the self-attention module to aggregate image and instance features. And then we use the text encoder to compute HOI embeddings for each HOI class. Then we use the HOI embedding for classification. We design a multi-branch network, including a global image branch, a union branch, and a human object branch. All these branches crop image features from the feature map and share the same HOI embedding weights. Besides, we use the scores from KNIP as supervision for model learning, where we use image scores for the learning of global image branch and human object branch, and the union scores for the learning of union branch. Please read our paper for more details. Our multi-level knowledge distillation strategy gets incredible results on widely used HICO-DET dataset. As shown in this table, our method is even comparable with some fully supervised and weakly supervised methods. We have extensive ablative studies on the model design, including the contribution of knowledge distillation from different levels, and we use different supervision strategy for each branch. Besides, we validate the generalization capability of our model. Here, we only select a subset of HOI category space during training and distillate the corresponding scores from KNIP. For example, 100 or 300. And for inference, we ask the model to generate HOI labels on the full set of 600 HOI category space. We observe the performance decrease is not severe, which validates our model is generalizable. We also present some quantitative results, indicating our method can deal with some hard cases like rare classes, small objects, and highly occluded scenarios. Finally, I will give a summary on this work. First, we propose a new task of zero-shot HOI detection where no human annotations are used during training. Second, we developed a multi-level knowledge distillation strategy from CLIP for this task. And finally, our performance is very strong even compared with weakly-supervised or fully-supervised method. Thanks for listening.